In this video, we'll learn how to use the sorted edges algorithm to find a low-cost Hamilton cycle in a graph. So much like the nearest neighbor algorithm, this algorithm finds a Hamilton cycle that has hopefully low cost, but it's not guaranteed to find necessarily the lowest cost Hamilton cycle. So as you can see, the sorted edges algorithm itself is what's called a greedy algorithm. That's the type. So what you do is you select the cheapest edge that you can at each step. And an edge being able to be added means that both of these properties hold. So you don't add an edge that would create a smaller cycle, create a circuit that doesn't contain all the vertices. And also you don't add an edge that would give a vertex degree 3. Because if you think about a Hamilton cycle in the end, each vertex has degree 2 because you just run through all the vertices and you don't repeat. So you wouldn't want to have higher degrees. And then you just keep adding edges that are cheapest that satisfy those properties until you have a Hamilton cycle. So let's start. We have to look at all the weights, all the costs on all the edges, and pick the cheapest one. So the first one we see is weight 5, and of course it's the first edge, so it's not going to violate any of these properties. So then I just start looking for cheapest edges, but I do have to keep these in mind. So I have two 7s, which is the next cheapest. To break the tie, I just choose one, so I'll choose this one since it's already connected to the edge that I chose. But I could have just as well chosen this one. And now I want to add this 7, but let's just make sure that we're understanding these properties. If I add this 7, it won't complete a cycle, because if I have 3 edges, a cycle would be a triangle, so not creating a triangle. And also it doesn't create a vertex of degree 3, because if you look only at the blue edges, this has degree 1, degree 1, degree 2, and by adding this edge, I would create a degree 2 vertex and 1, but nothing that would be degree 3 or higher. So we can add this one. So the next cheapest edge is this 9, but I can't add that because it creates a degree 3 vertex right here. This would have 3 blue edges. So I can't add the 9, which means it gets passed by. Proceeding, we see a 10. That would also create a degree 3, so we can't add that. There's an 11, but that would also create a degree 3 up here. So out of the question. There are two 12s. There's one here, and there's one here. And I can choose whichever one I want to add. So I'll choose this one. Okay, now we examine this 12, and this would still be okay, so I'll add that 12. Then we've covered, let's see, all the vertices, so I'm forced at this point to connect. If you view this as like a long path that starts here and goes around like this, I have to connect the starting and ending points, because remember I have to end up with a Hamilton cycle, so I have no choice according to weight. I just have to add this one. So this is my Hamilton cycle. It doesn't matter where you start, so we'll start here. You go around the 6 vertices and come back to where you started. So the weight, or the cost, kind of 2 words for the same thing, is just the sum of all the weights or costs on the edges of the cycle. So I have 5 plus a couple of 7s plus a couple of 12s plus a 13, and you would add all these together, and that's your total cost for the cycle. So again, this is the sorted edges algorithm, which has a similar output to nearest neighbor algorithm. They both give you a low cost Hamilton cycle, but this one uses a greedy method where you don't have to stay connected the entire time. And that's the sorted edges algorithm.